Section 7.4, Solving Logarithms. So log base 9 of x is equal to 3 halves. I got to find out what number that is. How do I do that? Well, you know what? I don't like it in log form, so I'm going to change it into 9 logarithms find exponents. So 9 to the 3 halves is equal to x. Now this I can do pretty easily. I'm going to say, well, this is the same thing as 9, the square root of 9 to the third. Why is it square root of 9 to the third? 9 to the 3 halves is the same thing as 9 to the 1 half times 3. That's a square root of 9, which is 3 cubed. And 3 cubed is 27. So x is equal to 27. X right here. 16. Log base 16 of x is equal to 5/4. Well, I'm going to change this into exponential form. 16 raised to the 5/4 has got to equal x. This is the base. Logs find exponents. That's the number. Log, this is the base, this is the number, this is, and it equals the exponent. And I can change it into base, exponent is equal to the number. So changing this around, I know this is the same thing as 16 to the 1/4 to the 5th. 1/4, well, that's the 4th root of 16. The 4th root of 16. Well, 16 is really 2 to the 4th. 2 times 2 times 2 times 2. So what's the 4th root of 2 to the 4th? It's just 2. And what's 2 to the 5th? That's going to be 32. Pretty simple. Same thing here. 2 log base 2 of 3x minus 4 is equal to 7. Well, this is base 2. Here's my exponent, 7. It's going to equal 3x minus 4. 2 raised to the 7th power. How do I get that? Well, I know that 2 raised to, I just found out 2 raised to the 5th power was 32. So the 6th power would be 64. The 7th power would be 128. Pretty simple from here. Add 4 to both sides, 132. And I'm going to get 43. Down here, log base 3 of x squared minus 15 is equal to log base 3 of 2x. Well, really, I don't have to do any fancy thing here because basically this is just saying these numbers inside have to be the same. So x squared minus 15 has to equal 2x. So now it's just a x squared minus 2x minus 15 is equal to 0. That's a nice easy quadratic for me to solve. I'm going to factor this. X minus 5 and x plus 3 is equal to 0. So x is going to equal 5 and x is going to equal negative 3. Let's do a quick check though. If I plug in 5 in here, it's going to give me 25. 5 squared is 25 minus 10 minus 15 is 10. Can I take the log of 10? Yes, I can. 2 times 5 here is 10. So we're good. If I plug in negative 3 here, negative 3 squared is going to give me 9. Minus 15 is negative 6. And that's negative 6. But can I actually take the log of negative 6? I can't. I can't take the log base 3 of negative 6. Because if that equals some number, let's call it y, that means 3 to the y is going to give me negative 6. 3 raised to any power here is always going to be positive. It will never equal a negative number. So this is what we call an extraneous solution. We cannot use it. So you always have to go back and check. Check your answers, plug them in, see if they work. And this is your first lesson on solving logarithms. Put in exponential form, that's one of the easiest ways to do it. Right here, once again, I just change it into exponential form. 2 raised to the 7th is equal to that number, and then solve from there. If the log is the base is the same on both sides, you're really just worried about the stuff on the inside being the same. But always go back and check for any extraneous answers. Thanks for watching.